All right, for our first unit for physics, we are going to be talking about motion, and specifically for the next few days, distance and displacement. So there are a few things that we're going to look at. We want to look at what is distance, how is displacement different from distance, and exactly what is a scalar quantity and what is a vector quantity. If you've never heard those words before, you're going to know by the next few days. All right, so we have distance. You have heard this before, since probably you were two. Distance is how far an object travels, okay? So it does not depend on direction. When we are talking in science, if we are talking about distance in this class, it does not depend on direction at all. Okay, so if we have this little ant right here crawling along on the ruler, so this little guy over here, and he goes all the way over to 3 centimeters. Okay, so his distance he traveled is 3 centimeters. Easy enough. Okay, so here's our ant again. He starts at 3 centimeters and he goes this way, and he ends at 0. He traveled a total of 3 centimeters. Okay, the thing is with distance is his direction, whether he's going forward, backward, right, left, north, south, east, or west, doesn't matter. Okay, it's just the total amount that he travels. All right, so if we have this little guy and he decides to go all the way to 5 and then needs to turn around for some reason and go to 3, he has gone a total of 5, 6, 7 centimeters. Okay, so his distance he walked is 7 centimeters. Okay, here's where stuff gets a little different. Okay, when we are talking about physics and in this class, we're going to call something displacement. Okay, so this is what we call the difference between where the object starts or its initial position and where it ends or its final position. Okay, this depends upon direction. All right, it does depend upon direction. All right, so displacement is equal to our final position minus initial. Okay, we're always going to do final minus initial, never the other way around. Okay, so you'll see it, we'll write it as change, a delta x, which means change in x, or x is displacement up here, which is equal to x final, so the final position, minus x initial, its initial position. All right, so for displacement, because we said it does depend on direction, we need to use a direction. All right, so the examples that we could have for that are positive and negative, northeast, southwest, or a certain angle. We are mainly going to be using positive and negative. We'll start out using these for examples of directions, but more than like after that, we're just going to use positive direction, negative direction. Okay, so for our ant again, his distance was 3 centimeters. Now, if we want to say his displacement, he walked 3 centimeters the first time to the right or east. Okay, so that would be his displacement, 3 centimeters east, 3 centimeters to the right. All right. However, this is important right here. An object's distance traveled and its displacement aren't always the same. So we've come back to our little ant again. All right, he went 3 centimeters, and we said he went 3 centimeters east, or in this case, we are going to use positive and negative. All right, so positive is always going to be away from 0. Okay, so if he starts at 0 and goes away, that's positive. If he starts away from 0 and goes back, that's negative. All right, so in this case, they're both the same. Okay, now in this case, our second example, when he started at 3 and went backwards, okay, he still went 3 centimeters, but in this case, his displacement was 3 centimeters in the negative direction, or negative 3 centimeters. All right, now here comes our complicated one. So we said earlier that our ant went 5 centimeters this way, turned back around and went 2 centimeters this way to land at 3 centimeters on our ruler. Okay, his distance was 7 centimeters. Now, what did he do as far as a displacement? So, him walking this way is a positive 5 centimeters. When he walks back this way, he goes negative 2 centimeters. Okay? So if you add up a positive 5 and a negative 2, you get 3 centimeters. Now, if you also remember, we said something about where the initial position is and the final position. Okay, our ant ended up final at 3 centimeters. So, and it's always final minus initial. So positive 3 centimeters minus 0 centimeters is also positive 3. Okay, so you could do it both ways. You could count him and do each direction added together like this, or it's the same exact thing as doing final minus initial, where he ended at 3, he started at 0, so he went a positive 3. Okay, this is another example I like to use other than the ant. So, if we have a track, this is a shorter track than a normal track that you'd use for high school. Let's say it's 100 meters around. Okay, so if we have this athlete that runs all the way around once, they go 100 meters. Okay, and it says they go around 3 times. They've run around another time, that's 200 meters, and around another time, 300 meters. Okay, the athlete's distance that they ran total is 300 meters. All right, however, their displacement is 0. Why? Okay, the reason that its displacement is 0, again, we always do final minus initial. Okay, the athlete starts at this white line, which is a start-finish line. Starts there, goes around once, twice, 3 times, and ends here. So our final and initial position is at the same spot. So guess what? Its displacement is 0. Okay, so the last thing we're going to go over real quick is a difference between a scalar quantity and a vector quantity. Okay, so these are just terms that we use in physics and in physical science to explain certain terms. So a scalar quantity has a magnitude or a number, but not a direction. So the one thing we just talked about that doesn't have a direction but has a number attached to it is distance. Okay, so distance is what we call a scalar quantity. All right, a vector quantity, on the other hand, has a magnitude or a number and a direction. Okay, so the thing we just talked about again that has a direction along with that number is displacement. Okay, so in physics, when you ever hear about something called a vector, it's always something with a number and a direction. And this, in our case for today, is displacement.